All right, we're going to work on some review questions for our Chapter 6 test. You've seen this first graph several times. This is the parent function of all quadratic functions. So we should know the shape of this. You could choose a few points. Remember, it's going to be a parabola. So we'll choose 0, 1, and 2. And we know that a parabola is symmetric, so when we get our values for 0, 1, 2, we can reflect over the axis of symmetry. So we're going to plug in 0. 0 squared is 0, so we have a point at 0, 0. We plug in 1. 1 squared is 1, so we have a point at 1, 1. And we plug in 2, and 2 squared is 4, so we have a point at 2, 4. And again, what I just mentioned, this is symmetric, so we have a point over here across from this one, and then a point across from this one, and we can graph our parabola. So we should definitely know the shape of this by now. We've seen it many times. All right, the next several examples on this review are graphing parabolas that are variations of this parent function. So it's still going to be a parabola, but it might be moved, or it might be made narrower or wider, or it could be flipped. So over here, when we look inside the parentheses, this has to do with whether it moves left or right. So what's added or subtracted moves it left or right. What's added outside the parentheses moves it up or down. The left or right, remember what we do is we think what makes this parentheses 0, and a 4 does. So it moves right 4. And then outside it moves up 4 because it's a positive 4. So this one actually moves right 4 and up 4. And we know it's going to be a parabola shape. We could plug in some points, and what we do is we plug in points close to the x value of our vertex. And so we will plug in 5. So we'll put 5. And we could just think through this. 5 minus 4 is 1. And that 1 squared is 1 plus 4 is 5. So we have a point at 5, 5. And then let's plug in 6. 6 minus 4 is 2. 2 squared is 4. Plus 4 is 8. So we get 6, 8. And again, we remember parabolas are symmetric. So we can put a point across from this one and a point across from this one. And there we see we still have that same parabola shape. So it's a little rough drawing there, but a parabola, their vertex is at 4, 4. The next two, what we're going to have to do is put them into our vertex form. And so what we do, I'm going to rewrite this down here. So we have y equals negative 2x squared plus 4x minus 1. And the constant, when we're completing the square, the constant's just going to remain out to the right for a while. We only complete the square and do work with this to start with. So the first thing we need to do is this x squared needs to have a coefficient of 1. So we factor out a negative 2. Make sure you factor it out of both terms. So factor a negative 2 out of the first term. We have x squared, which is what we want. Factoring negative 2 out of 4x gives us negative 2x. Remember, we leave a space here and we have this negative 1 out here. Even if, so negative 2 doesn't factor out of 1, so we kind of remember, but if this was a number 2 could factor out of it, still just stays to the outside. So now we do our completing the square. We are going to take half of negative 2, which is negative 1, and square it. And so negative 1 squared is 1, but there's a negative 2 out here that's distributed to it, so we didn't just add 1, we actually did 1 times negative 2, which is negative 2. So we subtracted 2, so in order to keep this balanced, we have to add 2. So that's the part where we completed the square, and now we can write this in its vertex form. So we got our -2 out here. Remember, when we complete the square, this factors to x minus 1 squared, the x coming from here, and the -1, we think of this. And then -1 plus 2 is 1. And so once again, we use this to tell us that it moves left or right. And in this case, it moves right again because we think what value makes this parenthesis 0, and it's a 1. So it moves right 1 and then up 1 from what's added outside the parentheses. So we have right 1, up 1. And we can choose a few values close to our x value, so close to 1. 0 is a nice value to choose, so we can put 0 in there. We can put 0 in this equation, or we can put 0 up here. In this case, it's a little easier to put 0 up here because we have 0 squared times -2, which is 0, plus 4 times 0, which is 0, minus 1. And we've talked about before, if we put 0 in there, we get the y-intercept. So this is -1. And let's go ahead and plug -1 in there. We'll just put another point to the left. I'm going to put -1 in this form. So thinking through it, we put -1 minus 1 is -2. Squared is 4. 4 times -2 is -8. Plus 1 is -7. And so we have the point -1, -7. And because this is a parabola, it's symmetric, so we can put a point here. And we can put a point over here. And we try to sketch in our parabola. And there's that parabola. On this next one, we actually have an inequality, so we will talk about that. So just as a review, if we have greater than or equal to or less than or equal to, those are going to be solid lines. If we just have greater than or less than, that's going to be a dashed line when we graph. And then we think of our signs greater than or equal to, sorry, less than or equal to, we will shade below. And if we have greater than or equal to, we shade above. So we'll have to remember that information when we get to the end and get to our graph. Actually, we can think of it now. It's a greater than, so we'll shade above. And it's got the or equal to, so it will be solid. So we'll remember that when we graph in a bit. We will have to complete the square again. So we have y is greater than or equal to x squared plus 2x minus 3. And sometimes we might think, oh, I think I can factor this. That's not what we want to do right now. We were going to complete the square to help us graph this. So I probably didn't put it far enough. So let's actually put our -3 is going to be out here further. And so what we want to do now is we want to complete the square. In order to complete the square, our coefficient of the x squared term has to be 1, which it is, so that's okay. We take half of 2. Half of 2 is 1, and we square it. And we didn't factor anything out here, so we just added 1. We didn't have to multiply it by anything out here. We did in this one because there was a -2, but we added 1, so we also have to subtract 1. And so our perfect square was easier to get to this time. We got y is greater than or equal to x plus 1 squared. And then -3 minus 1 is -4. So we are going to go left 1 because -1 makes this 0. So we go to -1 and then down 4. So -1 down 4 is the vertex. We can plug in a few points. It's like 0 is a good point to choose again. If we can choose 0, and again, that's helpful to put in this one. 0 squared plus 2 times 0 minus 3 is going to be -3. And then let's put in 1. 1 plus 1 is 2. Squared is 4. Minus 4 is 0. So we put in 1 and we get 0. can actually fill this in. We get -3. And we know that this is symmetric, so we have a point across from this one, and we have a point across from this one. Going back, we remember this is a solid line, and we shade above, so we'll go ahead and draw our solid graph. A little rough. And we want to shade above. So above ends up being inside in this case. So we shade inside there. And that's our answer. Those are all the points on the graph that would make this inequality true. Moving on to these aren't written very well. I'm going to change what this says. So this should actually be a function. So this should be something like y equals, or f of x equals x squared minus 7x. And this one I'm going to change completely because it talks about y-intercepts. Let's say, well, let's just use y in this case. Y equals, I'm going to change this to x squared minus 3x. So let's actually just rewrite this. Completely. So here we go. To find the zeros, we remember those are x-intercepts. And to find x-intercepts, we plug in 0 for y. And so we'll plug 0 in for y, which this f of x is our y, so we'll have 0 equals x squared minus 7x minus 8. And so we go to factor this if possible. If it doesn't factor, use quadratic formula, but this one factors, so we have x here and x here. We need a -8, so we need a plus and a minus. And then our factors of 8 are 1 and 8, 2 and 4. It looks like what will work here is a 1 and an 8. We can check that because we have 1x minus 7x, or minus 8x, which is -7x. We're not finished yet, though. Remember, we wanted to solve this, so what makes this equal 0? Well, -1. And what makes this equal 0? And that is 8. So those are the x-intercepts, or the zeros. The y-intercept, what we do for the y-intercept is we plug in 0 for x. Plug 0 in for x, which is pretty simple because we have a 0 squared minus 7 times 0 minus 8. So the y-intercept is 8, -8. We use the same concepts over here. I'm not going to rewrite this, but we use the same concept. So to find the y-intercept, or to find the 0, we plug in 0 for y. So we put 0 in here. We got 0 equals x squared minus 3x. This isn't a trinomial, but we notice we can factor out an x. So it doesn't factor like these, but we can factor out an x, which is even easier. We have x minus 3, and we think, well, what makes this equal 0? Well, that one, 0 makes x equal 0, and then what makes this factor equal 0 would be a 3. So those are the zeros. The y-intercept. Oh, this is a good one to check. We're going to plug in 0 for x. We get 0 squared minus 3 times 0, which is just 0. So our y-intercept is 0. So that's how you do those. Finding all roots. First, we can think of the number of roots. Whatever the highest exponent is, the degree is how many roots that will find. So this one will have 4. This one will have 3. Sometimes you can have a root that repeats itself. So what we want to do here, first thing we want to do is see if we can factor. And we can factor out an x. So notice that x is in all these. So we can factor out an x, and we're left with 3x cubed plus x squared minus 3x minus 1 equals 0. So that helps us find one root because we know x will equal 0 because of this. Then we have this part inside. Once we're down to this cubic function that does have a constant, we can try to use factoring by grouping, or we could try to use C over D. It does look like factoring by grouping is going to work here. So we still have our x out here. We'll leave that out there for a while. I'll put brackets to separate this out of the first two. So we're going to group these two. And then remember, if our third term is negative, we want to change this to plus a negative. So when we group, we don't change the value of our expression. And what we're going to do is factor out of here. It looks like we can factor out an x squared. So factor out an x squared. What's left is a 3x plus 1. Don't forget, if you factor out the entire thing, like we're factoring out the entire x squared, we do have to put a 1 here. Over here, to get this to look like this, because that's our goal, we have to factor out a negative 1. So we're going to have a negative 1, and then this would be 3x plus 1. And we have our x out here still. We'll still use brackets. We notice that we have this 3x plus 1 in common. So when we have something in common, we factor it out. We bring it to the outside. And then we think, well, what's left over? We have an x squared plus a negative 1, or just x squared minus 1. Now that we have all multiplying, these these brackets aren't necessary. And at the same time, we recognize this as a perfect difference of squares, so we can factor this to x plus 1 times x minus 1. And so our roots to solve this, we know x equals 0. From here, we have to solve this. 3x plus 1 equals 0. So we subtract 1 and divide by 3, so x equals negative 1/3. From this one, it's just what makes this 0, so that's negative 1. From this one, we have x equals positive 1, and so we put our answer all together. We get 0, negative 1/3, negative 1, and positive 1, and those are the zeros of that function. And our last one for now, we want to find the roots of this. This does not have anything in common. We can't factor out an x. Also, it doesn't fit factoring by grouping, so we'll need to use C over D. C, our factors for C are plus or minus 1. Remember, C comes from the factors of the constant, which is just 1. D comes from the factors of the leading coefficient, which are 1 and 5. And so C over D are all combinations of C over these D's. So we have 1 over 1, which is just 1. And then we have 1 over 5. So we don't have a lot of options, so it seems promising that this won't be too hard to find at least one. Sorry, I wrote that weird. So now we want to do synthetic division. We list our coefficients, 5, 9, 3, and negative 1. Don't forget negatives when they're in there. Let's go ahead and start with 1. So remember what we do is we bring down the 5. 5 times 1 is 5. 9 plus 5 is 14. 14. One times 14 is 14. Add those together and you get 17. This is not going to work. 1 times 17 is 17. And we get 16. So 1 doesn't work. Let's try negative 1. So we have 5, 9, 3, and negative 1. Bring down the 5. Negative 1 times 5 is negative 5. Add those together, we get 4. Negative 1 times 4 is negative 4. Add those together, we get negative 1. Negative 1 times negative 1 is positive 1. Add those together, we get 0. So negative 1 works. So we know that we have x plus 1 as one of our factors. We do the opposite of this. And then we can rewrite this now as these are our coefficients if we drop down one level. So we have 5x squared plus 4x minus 1 equals 0. And now we try to factor this. So we have two groups of parentheses. We think, how do we get a 5x squared? Well, we need a 5x and a 1x. How do we get a negative? We need a positive and a negative. And the nice thing is we're just going for a 1 here. So that's the only factors of 1 are 1 and 1. So let's put 1 and 1. Let's check it. We have 1x minus 5x, which gives us negative 4x, which is not what we want. We want positive 4x, so remember, if that happens, what we want to do is we want to switch our signs. So we have to switch our signs and make this negative and this positive. And now we can finish this out by solving. X equals, from this one, x equals negative 1. From this one, we have 5x minus 1 equals 0. We would add 1. So 5x equals 1. And then divide by 5, and we get 1/5. And then our last one, we see that this is x equals negative 1 again. We actually notice we get negative 1 twice. We only have to list it once. So our answer is x equals negative 1, 1/5. So it looks like we only have 2 answers, but really this was a cubed. We have 3 answers. It's just that negative 1 was an answer twice. And so there's the roots for this equation.